attendees are in listen-only mode.
Hey folks, welcome to another Wednesday webinar. Today we're going to be talking about AI, and we're going to specifically be talking about NPCs in Unity. So a couple of things to mention before we get started. I'm going to be minimizing the control panel for the webinar, so if you have questions, please feel free to post them, but I'm not going to be answering them till the end because I'll be hip deep in code and inside Unity. Second thing is I'm doing this a little bit remotely. I've kind of gone on holiday for a couple of days, which means that if you look out there, I have a nice view out of the window, but at the same time, the connection out here is potentially a little bit flaky, and that might mean that it all drops off, in which case I apologize and I will try and come back, but I may not manage it. So with all that said, let's get started. So what we're actually going to do to begin with, and I'll just jump over to the website that I've got this little example from. So we're gonna start off by talking about soldiers inside Unity, because the soldier model is always a good one to start with when we're talking about NPCs and stuff in Unity. It's nice, it's easy, and it allows us to showcase a few different things. And in true sort of stealing from other people behavior, here is one that Steve Gargolinski made earlier. Let me just turn notifications off. I can see that they're popping up in the background. So Steve Gargolinski made this thing up. Steve's a great guy. I forget where he is right now, but he has been. He was at 38 just before that hot mess happened. And he made this thing, so the first version he made back in 2010, as you can see, but he's updated it since then. And it's very simple soldier behavior scripts, and what we're going to do is we're going to look into how it works and then try and take it a little bit further. But this is the URL right here, and I will drop that. Let's see if I can drop that into the chat and send that to everybody. With a bit of luck that worked. If it didn't, then I'll make sure that it gets linked alongside the recording afterwards. So, and let's close, let's not close GoToMeeting, that would be bad. Let's close Chrome and bring Unity. So this is what the part is, so I've trimmed it down a little bit, and we're just going to look at one type of soldier inside Steve's example, and that's this Wonder soldier. And these guys have basically a behavior that takes them to a random point, and we're just going to start the thing up and see that in action. So as you can see here, they walk, they pause, and then they change direction and walk in a different way. And if we look at that in the scene, what you'll see is that you can actually see that white line getting drawn, and that's the debug thing that's been put in to draw a line from where the soldier is to where it's going to, so that you can actually see what's going on in the thing. So first off, stuff like this, I said this in the session I gave a couple of months ago. A lot of AI programming is actually tools programming, because this is a very simple, very straightforward thing, but immediately you want to be able to kind of demonstrate to people what's going on and why the AI is doing what it's doing. So to do that, what we have is a mono-developed script, because you can never have too many mono-developed scripts. And line 41 apparently is the important one. That one's here. So to draw something like that, you just use debug.drawLine, and that puts it into the scene. So that's always like a good trick to know for drawing lines and kind of all that stuff. Just as much information as the AI thing has, try to expose that so that you can actually see what's going on with the thing. So that's just a quick one to bear in mind. Important to mention is that we talk here about current destination. So that is the end of the line. So how is that getting picked? Well, if we go here, at the start of the thing, the base position is where the guy is just now, and then you choose next destination. The next destination is this thing called inside unit circle, which I've got my camera on, so I can talk with my hands a little bit. So what it does is it makes a circle that is a radius 1 circle, and you multiply that out by the wander radius, so that you make the circle bigger in the same way that you do a 0 to 1 random number, and multiply that by the actual range you want to target. And basically, what we do is we say the current destination is the base position. Base position is going to be the soldier's position plus a new vector 3, which is this round offset, the x and the y of that, because it's we're generating a vector 2, not a vector 3. And we keep so we use the y of the random as the z, and the transformed position.y is our current y. So we choose the destination, we set the enum, so we've got 2 states here, pausing and moving. We set ourselves to be moving, and we start playing the animation. And in the update, what we say is draw the line to where we're going. If we're pausing, well, we're not pausing because we've just set it to be moving. So we're in like a move state. So these are very stateful representations that we're working with here. In fact, you could almost say that it's a finite state machine. I mean, it's a very simple finite state machine, but it kind of is. And what it does is it says that the current destination is the thing that we just found up here, same line, and basically we just transform.translate towards that destination. So you transform.forward points at the current destination, and then you translate forward by the speed times the amount of time since the next frame. So far, so easy. And if we are within 0.1 of the destination, we set a pause timeout. We're going to pause for a bit. We change the state to be pausing, and we play the idle animation. Dead easy, very straightforward. The way this pause timeout works is that you actually are choosing an amount of time to wait for. So here you can see that that is actually a random thing, and they are at different times. So that guy and that guy, that one just arrived just before, and he's off again. He's waiting quite a little bit longer because it is this random, and it's set here. It's between 2 and 6 that is being set to. So very straightforward. We're getting stuff walking around very quickly, very easily. But one of the, there's a few things to bear in mind. Like one is if you go near this guy, he's not going to react to your presence. There's no intelligence. It's very wooden. It's very artificial. And one thing that you'll also know is that that guy's just walked over there and he's immediately spinning around and walking over there. So there's 2 things to note about that. One is that he doesn't actually turn. It just changes the orientation and points him in the right direction and moves him on. The other is that from a kind of behavior point of view, it doesn't make a huge amount of sense because it's not how we would as people kind of control that kind of behavior. We wouldn't walk forward, turn around, walk back, and this kind of, if you were to think about tracking this over time, it's going to look like some crazy kind of spider web of things, crossing paths and just not actually achieving anything. That's not how soldiers behave. That's not how people behave. So let's do something a little bit more fancy. So here we have patrol behavior. Oops, no, let's open the scene, not the script. So we're at the other end of this map. If I jump to the first person controller, you can see that we've got this kind of razor wire and we've got a couple of guys in this scene. So let's start that up. And you can see, let's watch this guy. So he's walking to here and then to here. And again, we're using the same random amount of pause. I think that's a really good thing, because like random pausing is human behavior, right? I mean, at the end of the day, it's not like you're going to walk to a waypoint, wait 3 seconds, walk to the next waypoint. You're kind of going to stand, you might have a fag, you might kind of lean up against the wall. These are kind of very human, kind of idle kind of experiences. And it has a variable amount of time. So that is realistic. But what's a little bit awkward about this one is you can see that he's got a patrol walking around this razor wire between these two wooden, they're not wood, they're stone. Stone is the word I'm looking for. And the way that we set that up is here. So if you look in the scene right now, you can see that route 1, point 1, is highlighted with the selection. Point 2 is there, point 3 is there, point 4 is there, 5, 6, 7, 8. That is the route that we've just seen the guy describe. So that is walking round that stone and wood. I don't know why I keep calling it wood. It's razor wire. It's anyway. The point is that we've actually laid that out as empty game objects, and we can move those around as we want. But the way that we put that together, if we look at one of the soldiers, is here we have an array of patrol points. And what that means is that we've basically got to define this patrol by hand, and we have to make it make sense, which is in some ways good. It's sometimes nice to have that level of control and be able to see what's going on, but at the same time, like, it's awkward and it's finicky, and it works if you've got like nine positions. But if you think about having a bunch of positions or a bunch of soldiers moving around doing different things, it's actually quite an awkward way of putting it together. I mean, just for this simple scene, there's 9 for route 1, there's 5 for route 2, 5 for route 3, 6 for route 4, and 5 for route 5. So immediately we've got like quite a large number of things to manage. But the other thing is that we can't, under this system, we can't actually combine them. But I think I'm getting a little bit ahead of myself. Let me look at my notes. Yeah. So let's, before we move on from combining them, let's just talk about how this is actually working, which is relatively straightforward. Let me just shift that out of the way. Okay. So basically what we have is we have the array that we were just looking at in the inspector, and it's an array of transforms. And effectively what we do is when we start, we set ourselves to have index 0. We've set our state to be moving to the next patrol point. Effectively, that's the same state as we had previously. We've got a two-state kind of system. And what we do is, because our patrol point index is 0, we get the current destination, which is that index in the array, the position of that index, and effectively we just walk towards that. So instead of it being a random position that we're trying to get to, it's the next in a fixed series. And when we get there, where are we? Here we go. When we get there, we do a delay, a random delay. We wait for the next move. We swap into that state. We play the next animation, and at the end of that animation and that time which is here, we go to this choose next destination, and that increments the index, and if the index goes out of bounds we set it back to be 0, so it just becomes a loop. And again, it's pretty straightforward. There's not a huge amount to it, but one of the problems with this is that it is, well, like I said, it's very kind of rigid. And it also can't, because what you're doing is effectively minimizing the, you're setting yourself on the vector that minimizes the distance from where you are now to the destination point. That's fine, but it doesn't actually take into account geometry. So if we were to get Patrol Soldier 1 and we'll sub position 9 instead of position 5. So what we should see, theoretically, is that that guy walks to there, walks to there, and then he walks through the stone, through the razor wire, trying to get to where the next point is. So if those patrol points aren't placed absolutely appropriately, like the system is not actually going to be able to cope with it. Equally, there's there's just no, like, if I get in his way here, he's not aware of me, he's not kind of rooting around me, and just in general, it's not really a great system. But one thing that I wanted to, so I will move on and show you how to fix this. The one thing that I did want to show you is just a very little thing in Unity that I notice happens quite a lot. So if I make the game window quite big, right, if I walk up to this guy, and obviously I can't see what you're saying currently, but can you see anything wrong with this situation? And if your answer is that you're about 2 foot taller than the soldier, then you're paying attention. You can look down, well, you can look through the back of his head, because yay for clipping, but like, you are kind of very much a kind of huge, hulking, great 9 foot tall dude in this, which is symptomatic of quite a very easy problem to get into, but a very easy problem to fix with Unity, which is, let me just dump this into the place I had it before. Right, if we look at that, if we switch the game off and we jump back and we look at first-person controller. So I believe this is just the default first-person controller that Unity gives you. All right, look at that and tell me what's wrong with this. So one thing is that it actually floats a little bit above the geometry of the world, which means that it drops down. No, maybe it's that. Yeah, it looks like it's going to drop down a little bit. But look at where that camera is being placed in relation to the height of the thing. And then go back and you think about where your eyes are in your head, and you've got this here, and this is about 6 inches. So where we need that camera to actually be in order to have the right kind of height relative to everything else in the scene is more in line with somebody's eyes on their head. So you're not lining it up with the top of the capsule, you drop it down, and you drop it down about there is going to work. And if we start that scene up again, and I give you the big game window again, or lose the game window altogether. And now we can walk up to that guy and we can see that we're about the same height. So that isn't quite as immersion breaking. but it is just a little detail that certainly if you go back and you play Halo, when they've kind of continued on with the Halo lore, they now say that Master Chief is this huge 10-foot tall dude. I have half an idea that that's a retcon because this kind of thing was in there where you were so much taller than everything. But that's maybe me just being quite uncharitable. Okay, so that aside, we've got this problem with our patrol points, right? And we don't want to have to lay out patrol points in that way, and we don't want to have to kind of chain together a route in the way that Steve did, because it's just miserable. I don't know how long it took him. I mean, I imagine it's reasonably kind of quick for a small demo that like he's put together, but at the same time, it's busy work. It's not the actual interesting bit of what you are trying to do. So what we're going to look at next is nav meshes. So let's, I'm about to load the script, not the scene again. In fact, let me just do it, and I'll do it in real time with you and show you how to do it. So for a start, let's kill off all the other soldiers because we just want to deal with that one guy. So we've got one soldier, and let's give him the real route again. So the way that the scene is set up, we want to swap over to the navigation window. So if you haven't got it open, navigation lives in the Windows navigation. Bang, here it is. And we can bake the nav mesh. So give it a second. And basically, what we've just done is said that everywhere, except there apparently, but everywhere in this scene is walkable. Well, we know it's not, right? I mean, we know we've got these stones, we've got this wire, so we need to have a rethink of that. So what we need to do is, in fact, all of these items here, and Steve's got this quite well set up, but we can do that. And so these are navigation static, and they are not walkable. Great. Straight away, take it again, and you can see that it's kind of marked out the areas that you can't go. And because my belief is that because of the shapes that Steve has used, rather than having a block, he's got like a convex mesh for these things. So inside them you can walk, but you can't actually get to the inside, so it's not a problem. And likewise, we can do that in the second camp where all the other stuff is, all these things. Highlight all of them, navigation static, not walkable, and bake the mesh again. And that's going to highlight that you can't walk around all that stuff. Great. So what we need to do now is change the way the soldier's patrol script works. And when we pick a point, what we want to do is use that nav mesh that we've just created. So if we edit this script, so when we update moving to the next patrol point, well, here we move by like getting the direct line of sight and moving. Don't want to do that anymore. So we're going to comment this out. And we need to do something instead. What we want is a component from the navigation menu called a nav mesh agent. And basically that says that the object that we're connecting that to is something for moving around nav meshes. So we'll do that. There's all these values, which I'm not going to go through. They allow you to tweak a variety of stuff and control kind of the nature of the motion. But we'll just get rid of that for now because we're not actually going to give too much of a shit about that. What we can do is here we need to tell our nav mesh agent to move to a new a new destination. So first of all, we need to know like where the navmesh agent is. So we'll call it private navmesh agent agent. And when we start up, rather than find this component every time, we'll track it down once, get component, navmesh agent, and we'll store that. So we'll cache that in this agent variable, and then we can refer to it all the time without having to do lookup. So here what we actually want to do is use that agent variable. And what we want to do is we want to say agent.setDestination get current destination. So that should start it walking in the right direction. Now there is going to be a slight problem, and that is one that when I dummied through all of this, maybe not. Let's see what happens. So, oops, compiler errors. Yeah. Always remember to use methods, not referencing stuff as a type. Okay, let's see what happens. So that guy goes to the first point and plays his walk animation and just carries on. So something has gone wrong, right? So let's go back to the code and see what might have gone wrong. Well, we set the guy moving, and then we test if we've reached the destination yet. And that's where we go into playing the random idle. So there's a good chance that we're not actually triggering that, so let's find out. So if we just kick out a simple message on the console saying that we've arrived, we'll be able to see that. So it would have popped up on that bottom bar, but it's all gray, so that isn't triggering. So let's look into why that's not triggering. So we've got our soldier, and we've got our control point. So that there and that there, so let's watch him walk up to it. So the point here is on by his feet, and where we're comparing it to is at his waist. So immediately we're probably not going to be able to do much here. So what we can do is we can do two things. We can jump over here and change this value to make it more able to actually reach it with the way it's set up. What we can do is we can take all the patrol points in waypoint in route 1 and just move them up to be at the guy's waist. Either way works. I prefer doing this, but you can solve it in code if you want. Either is totally valid. And now what we should have, theoretically, is oh shit. Oh, now my whole let me solve this problem that I've created for myself looks dumb because it looks like I'm actually trying to solve the problem. Theoretically, I knew exactly what the problem was. script. Okay, we're going to solve it by doing both things. Oh, maybe. Nope. Okay, so what we're going to do is we're going to open Patrol Nav Mesh, which is a new scene where I believe I have solved all these problems already. And we'll look at that and we'll show you how I solved them last time I did it rather than trying to do it in front of you. Let's see if this one works. So that guy goes there and stops. So this time it worked. I've forgotten what I did different. So let's open up the script and find out. But as you can see, this guy is able to move around on the nav mesh. And we'll get back to why that's important, and I'll demonstrate like the change in the route that we had a problem with earlier right after I show you how the script works, because obviously I was screwing that up. So we get the agent. We do that in the choose next destination. So I don't know what the difference is there. Nope, don't know what the difference is. But basically what we do is same sort of thing where we pick the index point, we set it to the destination, we've picked and cached the agent variable here, exactly as I showed you before. And I think the patrol points in this one are floating higher. They're only floating 0.1 high. Strange. Okay. Anyway, the point is that this works. And when we run it, when we show the thing running, and here we go 1, 2, 3, 4, 1. So that's going to involve walking in the previous version that we had. It would involve walking through that big stone. So let's just do it and see what happens. So there's 1, and he moved over for 2. That's 3. In fact, I'll give a top-down view here. Find the soldier. You can see that he's actually following round the edge of that to get to where he's trying to get to. So that is actually being very respectful of the path planning in the world. So where previously we had patrol points that were kind of hand-holding and guiding the NPC around the elements in the world, what we have now is a thing where we could actually just drop this down to maybe, we could almost drop it down to say 3 patrol points. In fact, I'll show you that just now. So create empty, new patrol 1, and we want that to be here-ish. We want it to get 0.1 apparently, and let's duplicate that twice. So we've got 3 patrol points, put one of them here, and put the third one here. So rather than kind of mapping out the guy's route, what we're actually doing now is putting the points of interest and where we actually want him to go to. And if we drop that there, that there, that there, do it again. All of them at 0.1. First one here, second one here, third one here. Jump back to the soldier, 3, everything you just saw me do a second ago. So theoretically, what we should see is that immediately he's going to go to that top corner, and he'll wait there, and then he'll automatically path find his way to the next point. And wait there. And then again, pathfinding as he goes and kind of following the edge of that wire to the third point there, and then he should complete the loop. And this is now two things. One is in terms of like the actual kind of the route that the guy is following is a lot more human. Because it's not just a sequence of straight line, stop, which isn't how like people behave. You know, you can see that he just curled and bent his path around that bottom corner. The second thing that it's giving us is it's giving us a hell of a lot more flexibility, because we're not actually having to describe a route for him to follow that respects the geometry and all the rest. And the third thing that it gives us is, if I can remember how to do this, we can actually set something. I don't think it's ideal to do it as a oh, apparently that's a pro-only feature, so we'll not be seeing it today, but we can set things up to be nav mesh obstacles. And basically that says that they'll, in real time, try to route around what's going on. So basically, that means that right in there, what we've got is just a very simple pathfinding system that's going to be pretty robust. And that ships inside of Unity, so this is kind of how to make the most of that. But if we go and look at it, you know, it's still, he's not reacting to the player, and for some reason I can push him around. I guess that's a Unity thing. But he's not aware of the player's presence, and that is kind of a problem. So what we're going to try and do, and it is a try because I didn't get time to prototype this one in the demo that when I was putting the demo together, is we're going to try to get a system together that is going to look at the player if you come within a certain field of view and within a certain radius. Because that is the kind of thing that makes NPCs go from being very wooden, kind of very kind of artificial, to starting to feel like there is some sort of intelligence there. Because, you know, people react to their environment even on a subconscious level, they want to kind of, if something, a bird flies by, then your head will automatically kind of follow it, and even without you thinking about it. And this is where a lot of sort of NPC believability falls apart, because stuff like that tends not to kind of come up. There was a scene, let me see if I've got that scene to hand. There was a scene in Bioshock Infinite, which was, in some ways it was a really good example of this, and in other ways it was like a really terrible example of this. So, yeah, here we go. So I hope you guys can see this. I'm not entirely sure that it'll play VLC over the stream. But if you see this, then as everybody's moving around, they are all looking at one very specific point in the world, and it's this big tower that's smashed apart and smoking. And it's captured everybody's attention. Stuff like this makes the world feel alive. This dude here has just pointed up at it. There are reasons that this particular scene doesn't work. The kind of problem that I have most with it is that that tower got smashed apart maybe 10 minutes ago in game time. So the fact that these people are kind of pointing to it, and if I start, yeah, okay. So this is the beginning of this particular section of the game, and everybody's freaking out. That guy's running over and pointing up, and it's very much like this just happened. That guy on the bench just stood up, and it's not the case that this just happened in the game. So I find that it's, in that sense, it's very immersion breaking, but at the same time, it's drawing your attention in and making this world feel alive, because they're reacting to things like that are in the environment, that are kind of that are making you feel like they're engaging with the environment in such a way that they could be perceived to be intelligent. And head look is another big thing for this. Being able to control where the head is and where it's pointing is absolutely huge, just specifically for the level of immersion and engagement it brings. But at the end of the day, I would love to get to a place where NPCs are able to kind of understand what the world is, so that they know what's important and can look in the right direction. But we're not there yet. But by dropping something and saying, "Hey, look at this," as you walk, look at this. As you stand, look at this. It's actually a really powerful way of just getting just slightly more engagement. And not only that, but 2 months ago, I believe, or maybe 3 months ago, when I was talking about procedural content, we did quite a lot about Perl and noise. And what's interesting is, if I bring up Sketch app, what we can do with Perl and noise is kind of have a thing. Is that just going to let me? No, maybe. Is have a system where the aim is controlled by Perl and noise. So Perl and noise is going to kind of give you, it's going to give you a very, well, this isn't at all what I want. Is that a freehand draw? It's going to give you a very kind of, it's a random function, but it's a very controlled function that's kind of, you don't get jags and spikes, and you're not going to get a high peak here and then a low peak, and it's very much more controlled than that. And what we can do with that is we can tie it into so that it's generating a two-dimensional result. So effectively, it's one of these for the X, one of these for the Y. And what that gives us is the ability to control the head look at controlled random. So if this is kind of my field of view here, then I can have the dude look this way and then that way and then kind of. but it's random, but it's also controlled, and it's not, it's not the case that it's kind of here, 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 which is equivalent to what we were doing with the wonder behaviors earlier, where it was very much jumping about. Using something like Perlin noise means that we can control it, and we can kind of say, okay, it's going to go up, peak, come down, and we're giving those very random characteristics, but we're making sure that it's not got those jumps. And that's very important. That jumping about is kind of the antithesis of immersion. So by combining that in, and looking at the time, I'm not actually going to have time to do this with you for the head look, which is convenient because I think it would be an absolute train wreck. But you can do it. I've just not implemented it before in Unity. And it would make, so this, when this dude walks, let's look at him again. Always with the soldiers, always. So you can see that he is looking and focused at the direction that he's going in. And now he's stood, and he's stood rigid. And now he's turning and moving. And again, there is no life to that. His legs are moving, his torso is kind of moving as it's needed to, thanks to the animation system. But everything in the top half of his body is so rigid and so heading in the direction that his body is facing, and that's just not the way that these, that soldiers work. The people, it's very important that we kind of try to capture realism, and this isn't real. I mean, the fact that we've now been turning corners and stuff is a step in the right direction, but at the same time, it's not a huge step. So we've got now, just from this demo, a very simple finite state machine where the guy patrols and pauses. And it's not hard to envisage how we would extend that. So we could have a state added in here for if the player is within the field of view, and we just test here and override if the player is in the field of view, set the patrol behavior state to approach player, and that would allow us to kind of to react to the player's actions, and that's a fairly easy, straightforward one to add in. Let me see if I actually have the project where I was working on some stuff like this. No, it's on my SkyDrive, Unity projects. Maybe this one. So this was another fork of what Steve was doing with his thing. And while that's loading up, I see that there is a question, which is a comment, not a question, saying that Unity is a good tool, which it is. I mean, at the end of the day, it's the tool that I know. I mean, I don't want to sound like I'm shilling for Unity here. I think, particularly with the new pricing model, UDK can be a good option, particularly with the new the education pricing. Going free for education is a really smart move for UDK, and I am kind of surprised that that Unity has been playing that one so stupid for so long. But hey, they have been doing, so maybe they will lose out. So while I just see if I can show you this this last script, in fact it's this one here, I believe. If you have any questions, we do have 10 minutes, and I would love to answer any questions on this stuff. But I hope that kind of what you've got out of this has been just a very brief overview of how you can kind of get things moving around and getting moving around smartly using the Unity NavMesh stuff. There's not a huge amount that I can show you detailed code-wise in only like 50 minutes, but I did try to kind of give you a sense. So this guy, while I wait for questions to come in, so this guy has a suspicion level which is here, and we initially set it to 0. And he has an alert level at 1,000, and he'll return at 200. And the way that this works is that you do a line of sight check, which is basically done here, which is a raycast, and we raycast from the soldier to the player and check the field of view, sorry, check the angle to see if it's within the field of view. And if we can raycast that line and we hit the player rather than hitting some other piece of terrain, then not only is there a direct line between the player and the NPC, there is also, because it's within that field of view, the NPC can see me. And that is going to increase suspicion, and we're going to do that here. And this is actually a thing I was playing with about decaying the level of suspicion dependent on how close you are. Because if I see you and you're right next to me, well, I'm going to be immediately suspicious. You know, I'm going to see you. I know who you are. I know what you are. I want to attack you now. If you're a long way away, then I might sort of be looking and squinting and trying to see what that is. So it's going to have a very different kind of effect on my suspicion level. Equally, if you think about the kind of guard behavior that you often see in these games, then you kind of break the line of sight, go hide, and the guard goes, "Oh, it must have been the wind." I forget what that one is actually from. I believe it's the Thief series. I've seen somebody moving around. I've chased them. They've gone away, and it must be the wind. Well, that's just nonsense, right? At the end of the day, it's very kind of important that suspicion decays over time, but not in a kind of not in that same way. We're not in a way that says, like, I'm going to return to be thinking, it must have been the wind. If I actually saw you, there's somebody there, and that's kind of where this increase in suspicion, decrease in suspicion, and spotted behavior. So basically, I believe if I run this, you guys might not hear it, but I think what happens is that if I get to a point where he triggers his suspicion, he starts running towards me and screaming, I believe. Although it might help if I actually open the scene. Nope. Reference script on this behavior is missing. Okay, don't know. That one's not going to work, but that's how that script works. And again, this is actually, so we've got the idle, we've got alert, and we've got attacking. So as he's alert, he's kind of going to be approaching, and then when he gets close enough, he starts attacking. And you can see that that is kind of an extension of what we were doing with the move and the pause. So you can see how you can extend these behaviors to kind of add more stuff in. So there's 7 minutes. That's basically everything that I wanted to show you, and we don't have any questions, so now would be the time to ask questions if you had questions to ask. So we've got a question here, is using a nav mesh better than the other methods? Yes, but also no. So a nav mesh is very good for pathfinding around things, and it takes a lot of the heavy lifting out of the kind of the pathfinding, the laying out, like we were showing with those waypoints for the route. The amount of design work involved in plotting how do I route this patrol around this bunch of stuff is significantly reduced, and for a larger kind of set of things, that becomes very significant. But if I open up, do I have it on that list? No. If I open up, so I've used nav meshes for another thing, which I want to show you, because it's something that you actually couldn't do with, well, you could do it there are other ways. It might take a minute to upgrade this project. Let's find out. So there are other ways that you can do straightforward pathfinding rather than just that A to B kind of distance minimization. But at the same time, like, it becomes a bit of a pain in the ass. So using nav meshes is great because it takes care of all that stuff. You don't need to think about it. But again, it's going to depend a little bit on your use case. So, for example, if you were doing stuff with like racing cars, well, that is not so much about nav meshes. That's about like splines around curves, because like there's a multiple ways that you can kind of go around the course, but there is only one path, effectively. Or if you're doing something in like a space thing, then nav meshes are kind of inherently, because it's a nav mesh, it's 2D. Now you can kind of extend it into 3D if you want, but it kind of gets a little bit ugly. So there are probably better ways of doing that in a 3D kind of space world where you can actually fly around. It probably wouldn't be appropriate for like dogfighting and that kind of thing. But for something like this, where basically what we have is, this is just me hacking around. I basically wanted to put together a real-time strategy camera and control system. And what I can do with this is I can select a unit, and you'll see that that one's lit up green underneath it, that one's lit up red. And if I right-click, then it's actually going to nav mesh and pathfind over the nav mesh to where I'm trying to get to. And it's going to do that going around objects. So like this here, it can't actually climb over this. So what it will do, hopefully, if I've clicked in the right place. In fact, let me show you this one. So immediately it's going round that hill. It's going to go around that cube. And it's going to have a think and push the cube out of the way. Okay, I guess that's viable. And then climb this hill. And doing that without a nav mesh is possible, but the amount of stuff that you're going to have to do to make it happen is complicated. So there is no answer to is the nav mesh better. What works for you is going to work for you and for your particular use case. But I think that is the answer to that one. So we've got time for one more question, if there is one. Anybody at all? Here we go. Have I ever used dynamic obstacles? I've played about with them in the context of another thing I was doing. I don't actually remember much about them. So for the purposes of specifically answering the question, have I ever used them, I can't talk intelligently about them off the top of my head right now, so let's say no. Although that's not strictly true. So before I head out, let me do this. So you can find out more information through the IGDA's AI Special Interest Group, which is, I think it's IGDA AI SIG. You can find me on Twitter as @LukeD. You can get in touch with me, luke@igda.org. And yeah, that's probably the best way of contacting me. I'll give you my website address, but there's not a huge amount of relevant stuff on there, and I'm not keeping it up to date because I'm busy at the moment. But you can find me at lukedicken.com. And feel free to keep in touch, and if you have any questions, I will try to answer them as best I can, or point you in some direction of somebody else who can. But with 1 minute left to go, all that remains is to tell you to keep coming to the webinars every Wednesday at the same time, and let's look at who we're going to have next week. because I have no idea what's going on next week. And the website's not loading, so we're not going to find out. Here we go. Here we go. So the next week is going to be game design, and it looks like it's going to be on game balance. So Chris Crowell, Sandy Chen, and Ian Shriver are going to be doing a conversation on game balance. So look forward to that next week. And in the meantime, I will talk to you later. Thank you very much for tuning in for the last hour. See you.